You know that feeling when you look at two pieces of Python code? They both do the exact same thing, but one just feels right. It's elegant, it's natural. The other one, well, it works, but it feels clunky. It's kind of like it was written with a heavy accent from another programming language. It isn't speaking Fluent Python.
So what is the secret? What's that invisible line between just writing code in Python and writing code that feels like it truly belongs there? Well, today, we're going to pull back the curtain on the single most important concept you need to know to achieve that fluency.
All right, to really get this, let's start with a simple example. We're going to look at a custom-made object that represents a deck of French playing cards. Now, on the surface, it seems totally normal, but as you're about to see, it has some, well, almost magical properties. So here's the class. It's called French Deck, and it's pretty simple. Under the hood, it just creates a list of 52 playing cards. But the thing I want you to notice, the key to this whole thing, is that it also has two special methods, _len and _getItem. Don't worry about what they do just yet. For now, just remember they're there.
Okay, so let's put our new deck to the test. What happens if we make a French deck object and just pass it to the standard Python len function? And boom, it works perfectly. It returns 52. We never wrote a .length or a .size method, but Python's built-in function just understands our object. How weird is that? So what about getting a specific card? Well, we can use the normal square bracket notation, just like it was a list. Deck 0 gives us the first card. Deck -1 gives us the last one. Again, we didn't write any custom code to handle this. It just works. And this is where it gets really mind-blowing. We can import the random module from the standard library and just call random.choice on our deck. Now think about that for a second. A function that we didn't write, from a library that we didn't create, knows exactly how to pick one random item from our custom object. We got all that power for free. And it doesn't even stop there. The deck is automatically iterative. That means we can loop over it with a for loop. We can even check if a card is in the deck. All of this rich behavior just came out of the box without us writing a single line of code for iteration or anything. So you have to be wondering, right? This is the big mystery. How can this simple little class, with just those two extra methods, plug so perfectly into the rest of the Python language and its standard library? What is the secret that makes this all possible? All right, it's time to pull back the curtain. The secret is simple, it's elegant, and it is unbelievably powerful. It all comes down to something called special methods, or as pretty much everyone in the Python community calls them, dunder methods.
Dunder is just short for double underscore. These are just methods whose names start and end with double underscores, like __len. Now here's the absolute crucial point. You don't call these methods yourself. The Python interpreter calls them for you when you use certain bits of Python syntax. Think of them like hooks or a secret protocol that lets your objects talk directly to the interpreter.
Okay, this right here, this is the magic trick explained. When you write len of deck, the Python interpreter sees that, and behind the scenes, it translates your code into a direct call to that _len method on your object. The same thing happens with deck of 0. That becomes a call to deck _getItem 0. This is the secret link. It's how Python's clean, simple syntax connects to the behavior of your objects. Now, the really important thing to understand is that this isn't just some cute one-off trick for making a deck of cards. This is the fundamental way Python interacts with objects of all kinds. It's literally built into the core design of the language. This whole system has a name. It's called the Python data model. You can think of it like a consistent API, or a protocol that makes sure everything in Python, from the lists and dictionaries that are built in to your own custom classes, behaves in a way that's predictable and consistent. When you add these special methods, you're basically teaching your objects how to speak Python, letting them use all of the language's best features. Let's just walk through the logic from Python's point of view. It's so simple. First, you write something familiar, like len my object. Second, Python looks at your object and just asks, hey, do you have a _len method? If the answer is yes, great, Python calls it. If the answer is no, it just raises a type error, telling you, sorry, this object doesn't support that. That's it. It's a crystal clear, consistent protocol. And that's exactly why this is so brilliant. As the book Fluent Python puts it, this consistency is one of the language's best qualities. Because once you get this pattern for one feature, you understand it for all of them. Okay, so you might be thinking, sure, this works for collections, for things that act kind of like lists. But to prove this is a universal idea, let's see how the exact same data model applies to something totally different, numbers and math.
For this, we'll use a simple vector class. All this object does is represent a two-dimensional vector with an x and a y component. You know, the kind of thing you'd use in physics or graphics.
Now watch this. By simply adding an underscore add dunder method, our vector objects suddenly understand what the plus operator means. We can just add them together. And if we implement underscore mul, they instantly know what the asterisk means for multiplication. We are literally teaching standard math operators how to work with our brand new object.
And this just nails the point home. Look at the pattern here. Using square brackets on our deck gets translated to underscore getItem. Using the plus sign on our vectors gets translated to underscore add. It is the exact same mechanism, the same consistent protocol, being used for two completely different kinds of problems.
So let's bring it all back home. We've seen the secret, we understand the mechanism, but what does this actually mean for you when you sit down to write your own code? How does this help you become a more fluent Python programmer? Well, the benefits are huge. First, your code becomes way more readable because everyone knows what square brackets or a plus sign means. You don't have to invent and make people memorize custom method names like .get_item or .addVector. You get to take advantage of Python's massive standard library, just like we did with random.choice. And honestly, the best part? You end up writing less code that does more, which is the definition of writing smart, Pythonic code. By embracing the Python data model, you're doing more than just telling the computer what to do. You're actually participating in the design of the language itself. You stop writing Python with that Java or C++ accent, and you start speaking its fluent native dialect.
You know, learning this one concept just opens up the entire language. Everything from context managers using the with statement to asynchronous programming with async and await, it all follows this same dunder method protocol. So the only real question left is, what powerful features are you going to unlock next?